This cam has a high drop on it, so if you find that you're nicking the leading edge as you're grinding, what you would need to do is set the latch back in position and then rotate the lip up just a little bit, change the timing slightly, rotate it up off the setting blade, come back in, when you do the 3-flute core drills on these machines, you're actually going in and out 6 times on the cam. So what happens is it leaves sometimes a high heel on the end of the drill. To get rid of that, you would index, once you're done grinding, just go to your number 4 slot or your number 8 or 12. They're equally spaced, they're under 20 degrees apart. Set the latch there and feed in and grind the heel back off the drill, making a secondary cut. Then you go to the next float, just pass the wheel across, and go to the third and finish up. So you're going to end up with a radial relief on the front cutting edge and a flat backed off secondary. This is showing the operation of grinding the 3-flute core drills on the Model 252. The 252 differs from the 250A and the 380 in that it has a double cam setup. As we're rotating the tool, I have it set here with a number 24 cam, that's for a 3-flute, right hand. Use the large diameter cams here on the outside and use the regular cams for the even number flutes, the same as you would on a 250A or 380. To grind the core drill, I would set up the same as you would on the other core drills. You set your work head at 128 degrees, that is 10 degrees to the right of the angle that you actually want to put on the tool, because we're not going to be using any oscillation in this operation. You would set the tool, put the lip on the tool at any location you want, put it in the right-hand slot. Recommend setting the clearance relief at about 8 or 10 or 12, depending on the material you're drilling in. And just grind around. This next section is on regrinding the step drills. So I'm going to go through a couple different ways of grinding them, and these are for the step drills and also the subland drills. With the step drill, you grind the point the same way as you would grind the point on any drill. So that's usually done in a second operation. You grind the points and do the steps, or the other way around, doesn't matter. To set up the grind, you use no oscillation, and you also use the number 6 cam. That's used for a 2-flute right-hand step drill. If you have a left hand, use number 5 cam. So load the cam in. Set here. Now the angle that you want to set up the grind, again, without the oscillation, you have to move it 10 degrees to the right, off center. So if you want to have a 90-degree included angle step, we would set it at 100. Put it in the right-hand slot. Just set the lip of the drill out at a convenient spot. Bring your grinding wheel over. Now when you're grinding these, make sure that you have a nice sharp corner in the wheel. You don't have too much of radius. And it may help to use a finer grit wheel for doing this type of work to hold the form in the corner. Don't want to make too much undercut, just enough to put the radius of the wheel behind the land of the drill. Set your cam relief anywhere about 14, 16. Bring it in and grind. When you're grinding this way, you do tend to undercut the drill, so as you grind some off, you should also back your wheel back a little bit at the same time every few passes, so that you don't make too much of an undercut on the drill. Now there's another way of grinding the step drills too. Now this method you do not get an undercut. To do that, you would you'd first, using your angle dresser, dress half the angle on the wheel that you want on the point. Say if you wanted a 90-degree included angle on your step, you would dress a 45-degree angle on the wheel. Then you would set the drill straight, work head lock straight in, and then come straight down, so you're feeding down the axis of the drill so you don't get any undercut. If you do want a slight amount of undercut with this, you're going to have to use a dish or cup wheel that's recessed on the side. You don't want to have a flat side on the wheel when you're doing this type of work. And if you're doing a 180-degree included step, you have to use an undercut wheel, otherwise you'll be grinding the side of the pilot when you're grinding the step, and you'll leave there's no way to eliminate the problem of the radius with the grinding wheel. Also, when you're doing a 180-degree step, you can use another method other than using the cam grinding. What you can do is use the index type grinding. In this case, then you would do is set up with the latch in the number 1 slot, set the lip of your drill, bring the grinding wheel in close, then what we do is drop the grinding wheel down below center. I recommend, say for grinding secondary relief or grinding the heel back, that you would drop it down to about 30 below center. So this is going to be ground like the relief on an end mill, primary and secondary. You would grind the secondary on both sides to clear the heel, and then you can do is lift up probably to about 10 on your scale, and then feed across again to grind a primary. This way you don't get as much of a radius on the edge. When you grind the cam, you always get a certain amount of radius. But this, if you have a very sharp wheel, you can almost eliminate all your radius. And that's why it's sometimes better to do this on a 180-degree point. Now if you have a subland type drill instead of a regular step drill, the technique is pretty much the same. You do have to, instead of rotating all the way around, you're going to have to rock the drill back and forth. You do is you bring the wheel up toward the drill, and on the subland you have a secondary land that runs from the point back, and you don't want to rotate around far enough if you're going to nick that edge. So you would bring it in and just rock to clear the step and keep feeding in, and again occasionally backing your feet up so you don't get too much undercut. Rock it through all the way, then zero the feed on the cross feed here, bring it back, index to the opposite lip, and then feed back and grind back to 0, so that you're going to get it evenly ground on both sides, but you're not going to come around and nick the land. And with this type of drill, you also, on your flatter angles, would have to use an undercut wheel, a dish, or a cup wheel, so that you don't nick the pilot as you're coming around. When grinding the step drills and you're trying to maintain the lengths, say you want to have a certain distance between the drill point and the drill step, you have to keep track of how much you're grinding off of both. So initially you would have to, say, measure the lengths on a comparator or on a scale, depending on how accurate you have to be. Put the tool in the chuck, and then when you're grinding the point, you would come up to it, and when you reach, you would start to grind, and when you reach your outside corner, that's your reference point, you then zero the slip ring on the feed and grind off a certain amount, a certain set amount, to sharpen the drill. And then you would have to document this, because you're going to be doing the step and a second setup, so you're not going to be able to go right from one to the other. You would grind that amount off, and then you would have to grind some material off the step as well. Now, if you have different angles between the point and the step, you're going to have to calculate the amount to grind off because of the difference in the angles. And again, when you do the step, you would come in until you touch the shoulder, zero the feed, and then grind that amount off the step. Another way of doing that is to, if you're doing a lot of these, is to make a small gauge that you can slip on to the tip of the step drill. With that, you would have the chamfer on the gauge to sit down on the step, and you would have the top of the gauge would be the point where you'd have to have the tip ground back to, and you can even have a small notch in there if you have a minimum maximum, if you have a certain amount of tolerance that's allowed on the pilot. So with that, you can set it, grind some off, and actually check it with that right on the machine. You don't have to take it off, and then you can come back and grind more off one or the other if you need to. If you're grinding angles that are less than 80 degrees, included angle, you can't swing the workhead from this angle. You need to swing it around to the opposite side. Now what happens when you do that is you get the setting blade in the way, as you can see. There's this pin below that locks it in position on the other side. You can pull the pin, let it swing back out of the way, keep it on this side. Then to locate the tool, you would just set it so that the cutting edge is roughly level with the step and swing it away. Now in this case, this is a 60-degree included angle on a combined drill and countersink. Again, you always set it 10 degrees to the right, so you'd be setting it beyond 10 degrees beyond the 60. And now when you're over on the left hand side of the scale, actually the numbers are getting smaller, so in this case you set it at 50. Once the tool is set in place, you can switch on. Come around. And grind. You should have it, your clearance relief set probably be about 14 to 16. On the scale here. And again, watch out for your undercut. Back your wheel back a little bit as you're going so you don't get too much. And with this type of angle, you can also dress your wheel, so you can actually, by dressing the wheel, you can come straight in and do any angle you want. This is going over the making of step drills. Basically, the step drill has 4 different types of grinds. It has the grind on the point, which is the conventional drill point type of grinding, and it has the grinding on the step, which covered in the previous section under the resharpening of step drills. And the other motion you have is the grinding the pilot down to size, and also relieving the pilot. That's grinding the heel of the pilot and leaving a land on the back edge. The first step you usually do in making a step drill is to grind your pilot down to size. You don't use the cams or oscillation, you just rotate the drill. You have the workhead swung over so it's parallel with the grinding wheel, and the locating pin is in the hole. You slide over, drop it in, and then lock your lever on the side here. And you switch it on. Initially you should grind your pile a little bit over length, and when you go to do your pointing or your stepping, you can bring the pilot back to length. Feed it in till you touch, then set the slip ring to 0 on the infeed. And continue feeding in. Now keep in mind that what you're doing is you're grinding off thousandths off the radius of the tool. So actually you're taking twice that amount off the diameter. So if you want to grind 40 thousandths off a drill, you would grind set to go 20 thousandths on your dial. So when you ground the right amount off, just let it turn over slowly, let it spark out, and when you are doing this grind, you crank counterclockwise. If you do grind a lot off the drill, it's best to, when you bring it into the indicated point, is to check it with a micrometer, because you do get some wheel breakdown, and that can change the size a little bit. So you may have to go back and just grind a couple thousandths more off of the drill. So then once this is ground to size, then your next step would be to either point the drill. If the drill already has a point, you can leave it the way it is, and then grind your step back so that you get the right length of the pilot that you want. This is showing using the radial relief attachment. The radial relief attachment is used to relieve the pilots on drills. So if you're making a step drill, you're left with cylindrically ground pilot. That'll tend to grab in the hole. So what you want to do is relieve the backside and leave a small land on the cutting edge of the drill. This shows the actual relief attachment in the chuck. What you would do is take the spindle, put it in the chuck, clamp it in place, and then this is the finger assembly. This is screwed down into a socket in the front on the base. And this is the bar that it slides in and out, and you can lock it here. That sets the cross on the finger to get it underneath the margin of the drill. The finger height can be adjusted with a locking bolt right here. You want to position the whole unit so that you're actually going to be riding on not on the cutting edge here, but actually on the heel of the flute. So as that comes forward, that's going to follow the flute, and you're going to go along the grinding wheel and actually grind the back side of the drill, not actually on the edge, but right on the heel of the flute. Now in setting up the angle here, if you have a short pilot, you can set the workhead up so it's perpendicular to the outside of the grinding wheel. So as it comes along, it'll grind right along the side of the wheel. If you have a longer pilot though, what will happen is as you come around, you'll actually hit the front edge further out on the pilot. So I'll set this off a little bit off center. Just a hair is all you need to do. A couple degrees. Okay. Now that I have that set, what I can then do is bring the grinding wheel over before you turn it on, and bring it along there. Then turn the wheel on. feed until you touch, and then to actually take more off, that is, come closer up to the outside of the edge of the drill, you would simply feed the grinding wheel in. Do that until you have a thin land on the one side. Then you can pull back, index over to the opposite flute. And just take it all off on the one side. So that leaves a little margin actually right up on the drill and relieves the pilot so it doesn't drag. This uses R8 collets in the fixture, so you're limited to a 7/8 inch drill diameter, and you can also get collets for number 2 and number 3 Morse taper. So suggested in the setup is to move your grinding wheel away initially so that you're only touching right on the back of the flute, and then bring it in a little bit at a time, and that way you're not going to take off too much the first pass. After you've done this part, then you can grind the step back to length. Okay, this next section is about grinding the taps. You can, by changing your cam, grind the 2, 4, 6, and 8 flute taps, and on the 250 and 380, and some of the 3 flute as well. You use the number 4 cam for the 2 flute, number 8 for 4 flute, 10 for 6 flute, and 16 for the 8 flute, and that's the right hand, and also the complementary left hand cams too for these. Now in this case, I'm going to grind the lead on a 4 flute tap. So I use a number 8 cam for right hand, set the latch in the right hand slot, set the tap in as close to the chuck as you can, and then set the lip right on top of the setting blade. Pull the blade back. Now the angle that you want to set these at is determined on whether you're having a taper or a plug or bottom. Now these angles are not too standard. They depend a bit on the type of the size of the tap and the pitch of the thread and all. But roughly, a taper tap would be setting on the right, again on the right hand side of our scale, would be 152 degrees for taper, and you would set your cam relief at about 16. For the plug tap, would be set at 145 degrees with approximately a setting of around 12 or 14 on the scale, the clearance relief. And then to do the plug lead, you would set your cam relief at about 0 to 4, somewhere in that range. You'd use variable relief for those, and set your angle over at 120 degrees. Now these vary quite a bit, and for special applications you may want to go in between, so you're going to have to go in between on the angles as well as the cam relief to see what works the best. But I have this set up to grind a plug lead right now, so I'll turn it on. Now, these are all ground on the side face of the wheel. So as you bring it in, you're going to bring in the cross feed in. You ground enough off, just let it spark out. And when you do the different various taps, it's best to move your wheel back and forth. Don't keep grinding them all in the same place. After you have the lead ground, then you can swing the workhead over. Swing it over so the pin drops in the hole in the center. That locks it in straight. cam off. Spin the face down. If you have a lot to take off, say if a tap is chipped, a lot of times they'll be chipped in the first full tooth, it's best to first cut the taps off or at least rough grind them back before you start. Otherwise you'll be grinding and grinding this way. And it's important to get it perfectly flat so that all your teeth are going to be the same height when they engage in the hole. Otherwise you can end up one lip high and it's going to chip or break the tap. The 3-flute taps on the 250A and the 380 are ground a little differently. In this case, you use the number 10 cam for the right hand 3-flute. Again, latch in the right hand slot. Set up here at 145 degrees. Load the tap in. Set the lip of the tap. On some of these 3-flute taps, it's very similar to a 3-flute cord drill or 3-flute countersink with this model, is you'll end up getting a high heel coming back up. That's because the cam is actually going in and out 6 times, and it may not be camming all the way around before it comes off the cam. So then what you'd have to do is, if you do have this high heel condition, would be to index around to number 4, 8, and 12 slots to grind the secondary on the heel. So I'll put it in number 4 slot. Grind the heel back on 1. And then the 3rd flute. And that will clear the heel so that you have enough clearance on the drill, the tap. This is the operation of grinding the 3-flute taps on the Model 252. For grinding the 3-flute taps, use the number 24 cam. Now the same operation be used for the 5